Hello everyone, welcome back to the Python and Pandas tutorial series. And this is video 2 of Polymorphism series. In the previous video, we have seen the introduction to polymorphism and we have covered method overriding, which is runtime polymorphism. And today we will see about method overloading and how to use polymorphism in functions. To start with method overloading means defining multiple methods with same name but different parameters in a class. So we will be having multiple methods that have same name but the number of parameters or the data type of the parameters will be different. It is very common in Java, C++, C# languages because they allow multiple methods with same name but different arguments. But by the nature of Python, it does not support a true method overloading because function definitions are overridden if the same name is being used multiple times. So the latest copy of the latest definition of any method will be considered as the original execution. For example, let us switch to Visual Studio Code, and if you remember from our example in earlier video, let us uncomment that again. We had this one. So we have seen a sample class with a method greet which accepted a no arguments in one version and single argument in another version. And when we executed this, we have seen some error. So let us do that again. If you run this, hello Raja is printed because we have provided the parameter value over here. And if we remove that and if we try to access this version of greet, you can see you get some error because you are not providing any value for one argument or one parameter name. So what Python did is it forgot about the method greet which is not accepting any parameters. So it has information only about the greet method which will accept a single parameter. So Python is recognizing the last definition of the greet method here and the previous method is overridden already. But what if we need such behavior? Because this is supported by other programming languages like Java and C#. And what we need to do if I want to achieve the same functionality, like I should have the method name as same, but I should be able to use that for multiple types of or multiple number of parameters. So that can be achieved in Python. Maybe we can say that can be simulated in Python. So method overloading in Python can be simulated in two ways. One is using the default arguments and the other is using variable length arguments, or we call that as star args. We will see some examples. So what I will do now is I will remove this for now. We don't need this. And when we have a sample class with greet method which accepts one parameter, the first way of simulating method overloading in Python I said is using default arguments. So if you remember, when we were discussing about providing some default values to our arguments whenever we are creating methods, we can provide some default value over here and that default value can be like this. Okay, and if we define a function like this and if we call greet method, now we see only hello over there, and if we call this with Raja, and we can see hello Raja is printed over here, right? So this is one way, and let us see another example of this. Comment this and write another class, maybe some other example, and define a function show, and it accepts self a equal to none and some other parameter equal to none. So we have this none which can be assigned to the variables here so that it will be treated as optional kind of thing. So we can write something inside the method like if a is not none, correct? So we will negate. So we have we did not have any value. Right, so if A is not none and B is also not none, then it means we got two parameters for the method show. In that case, we can print two arguments provided and we can write those as well if required. Okay, so those are A comma B. And what if means we can write maybe another condition L if. So now we don't have two parameters. We have only one parameter. So A is not none. In that case, print one argument is provided and that is A. Got it? Else. So means we did not get any parameter at all. In that case, print no argument provided. Okay, we did not get any argument. And now if we create some object for this example, maybe ex1 or e1 equal to example, and if we call e1 dot show without any parameters and e1 dot show by providing one parameter maybe 5 and e1 dot show with two parameters maybe 10 comma 12, and if we see we will not face any issue, we will not encounter any error. And for the first version we will see no arguments provided because we did not pass any arguments, and this 43rd line will be resulted in one argument provided and the value will be printed will be 5, and this is two arguments provided 10 comma 12. So if we clear this and run this again, you can see the same thing. No arguments provided, one argument is provided 5, two arguments provided 10 and 12. This is how we use the concept of default parameters to achieve the concept of method overloading in Python. Similarly, we have one more concept called star args in Python, which accepts, or we can say star args is for flexible number of arguments. So it will accept any number of parameters we provide. For example, we will take the same example class example and we will write single function and def the function is show, and in that accept self, and here instead of comma separated values and providing some default values, we write args, star args like this, star and followed by args, and in this we just print maybe arguments provided and followed by args. You can see this, these are the number of values. Okay, and it prints the values to a stream, this one actually. So and we write like this. Okay, there is a typo, so args. And if we call this by creating an object like the same thing, and if we uncomment this, so we will be creating even of example, and we call without argument, one argument and two argument, and maybe we can try providing some 1 comma 2 comma 3 also, so 5 arguments, and clear the console and run this again and see what happens. See, now even we don't have that branching strategies, what to do, how many number of arguments we need to check on, so such kind is not required, and simply how many number of arguments you pass, that will work with this, because it will be taken into the flexible arguments list star args. Okay, and all those will be printed over here. Okay, so if we use star args, the benefit is like it is allowing flexibility in the number of arguments, and it is especially useful in functions where we don't know how many parameters will be passed. Maybe if we are asked to write a function to add numbers, that's all, we did not say how many numbers user are providing. User may provide single number as an argument, or two numbers, or three numbers, or anything, any number of numbers, so that we need to calculate the sum of all those numbers and need to present on the screen or return some value. In such cases we can depend on the flexible arguments or star args. And let us see the concept of polymorphism in functions. So Python allows functions to be written without knowing the exact data type of objects they will work on. Okay, so we will see some example of using polymorphism with functions. So my function does not know what object type it should work on. So for that, let us take some example class car, and in this we write a method, maybe speed, and what it does is it simply returns the speed or some message. Car speed is maybe 100 kmph. And similarly, we do have another class called bike, and it also has speed method, and it returns bike speed is 80 kmph. And now we will have one function that prints the speed usually, and we don't know what object it will get, so we can take some variable instead of a or vehicle. Okay, and what it does is it simply prints the speed of the vehicle, or it calls the speed method on the vehicle actually passed over here. So if it checks for the existence of speed, and if available, that will be called. And now if we create an object C for car, and if we create an object B for bike, and we call print speed on car, I mean by providing car as input and bike as input, we can see car speed is 100 kmph, bike speed is 80 kmph. Both are executed properly. See, now here we did not know what vehicle is being passed to the print speed method. For example, let us try train, and we don't have speed method. And if you try to create t equal to train and try to access print speed method by providing, see here what happens. You got an error because it tries to get the speed method from the parameter which is actually passed, because we don't have speed method in the class which actually provided as argument for the function which we are calling. It returned an error. So if we have speed method, then it will be considered maybe 250 kmph. Now it works properly because we have added one speed method to the train class as well. So especially here we don't need to check what object is being passed to the print speed function. So in that case, we will use the concept of using polymorphism in functions. So just to recap, we can achieve method overloading in Python in two ways. One is using the concept of default arguments or default values, and the flexible arguments using the star args. So these two simulate the concept of overloading in Python. And we can write some flexible functions, we can say. Means the functions, those can accept objects of any class, any different classes with similar method names. Okay, that is using polymorphism with functions. So in the next class, we will see how polymorphism works with classes, and or we will cover the concept of operator overloading and duck typing in Python. Thank you for watching, and please don't forget to like and subscribe.